Yeah, welcome back everybody. We're taking more questions today. We already did up to number 10 of this exercise. So let's go to the next one. Let's go straight to the next one, and that's number 11. Let's see the question. The question is, two planks of lengths 1 meter and 1.2 meters lean against each other as shown in the figure below. If the angle between the planks is 36 degrees, how far apart are the bottom edges of the planks? And question B, what angle does the longer one make with the floor? Question A, how far apart are the bottom edges of the planks? B, what angle does the longer one make with the floor? Alright, so let's get the diagram first. It's number 11. This is a diagram. It's just a sketch. This is the floor. Now this is 1.2 meters. This is 1 meter, and the angle between them is 36 degrees. Now the first question is question A. It says, how far apart are the bottom edges of the planks? That means we want to find this distance. Let me call it x. If I call that x, using the cosine rule, x squared will be 1.2 squared plus 1 squared minus 2 times 1.2 times 1 times cos 36 degrees. And that, let's check that, 1.2 squared plus 1 squared minus 2 times 1.2 times 1 times cos 36 degrees, and that's 0.4984 approximately. So x is equal to the square root of that answer. So x equals square root of, or let me write that first of all. Let me write that value. That's 0.4984. So x is therefore the square root of that value. Square root of 0.4984. So square root of answer, which is 0.706, or let me say 7059. But they said we should give distances correct to 3 significant figures, and that's going to make it 0.706 meters. Now to question B. Question B is, what angle does the longer one make with the floor? That means what angle does the 1.2 meter plank make with the floor? That's it simply. Let me copy the diagram and put it down and paste it here for question B. Now what angle does the 1.2 meter plank, which is this, does it make with the floor? So let me call this angle theta. That's the angle the longer plank make with the floor. That's the angle the longer plank makes with the floor. So I can use sine rule here. 1 meter over sine theta will be equal to x over sine 36 degrees. So 1 over sine theta equals x over sine 36 degrees. When we cross multiply and make sine theta the subject, sine theta is going to be equal to, or maybe before then, let me put the value of x. 1 over sine theta equals x, which is 0.706 over sine 36 degrees. So now when we cross multiply and make sine theta the subject, sine theta will be equal to sine 36 degrees over 0.706, and that's equal to sine 36 degrees divided by 0.706. That's 0.8326. So theta Therefore, theta is the sine inverse of 0.8326, and that's sine inverse of that answer. Oh no, sine inverse of the answer, and that's 56.3. Let me do that again. Sine 36 divided by 0.706. So the sine inverse of the answer, that's 56.36, 56.36, and that's approximately 56.4 degrees. So the nearest correct to 0.1 degree. So the angle the longer plank makes with the floor is 56.4 degrees. Now to the next, which is number 12. The next is number 12. Number 12. An aeroplane flies due north from Ikeja Airport for 500 kilometers. If they say due north, if I have the 4 cardinal points here, and they say due north, that means directly up this way. If they say due east, that means directly to the right. If they say due west, that means directly to the left. So that's it. Let's take that again. Now, an aeroplane flies due north from Ikeja Airport for 500 kilometers. Let me even draw the diagram as I go. Let this be Ikeja Airport. Now, if it flies due north for 500 kilometers, then it will go directly up for 500 kilometers. I'm making this 500 kilometers. I want to put another cardinal point there. I always say that it's good to put cardinal points at every point in the diagram. So let Ikeja Airport be point P, and the point 500 kilometers where the aeroplane flies to, let it be Q. Now, and that point is due north of P. It then flies on the bearing of 060 degrees, which is just 60 degrees, for a further distance of 300 kilometers before overflying a road junction. Of course, you know that this is a ground level, so the road junction can only be somewhere around here on the ground. So it's good to be able to visualize the diagram too before sketching it. Now, it then flies on a bearing of 060 degrees. Let this be 60 degrees for a further 300 kilometers. So let this be the bearing, 60 degrees, and the distance it flew to 300 kilometers. Let this be where it stopped. It is here now, and this point is 300 kilometers from Q. Yeah, let me call this point R. Now, it flew to that point before overflying a road junction. So the road junction is going to be somewhere around here. Let's say the road junction is here. Is my line straight enough here? Maybe that's much better. Now the road junction is somewhere around here, and okay, so that's where it is, and the road junction is somewhere around here. Calculate the distance of the aeroplane from Ikeja Airport when it was directly above the road junction. So if it is directly above the road junction, it means if the road junction is here, the aeroplane will be directly up above that road junction. directly up that road junction, and I can complete the diagram by joining P to the road junction. So let the road junction be S. Let the road junction be S. Now that's a sketch of the diagram. So what's the question? Calculate the distance of the aeroplane from Ikeja Airport when it was directly above the road junction. That's the first question. So the distance of the aeroplane from the airport when it was directly above the road junction is going to be distance PR. The airport is P, and where the aeroplane is point R. So distance of the aeroplane from the airport when it was directly above the road junction is going to be distance PR. So now let's begin. Let's see what we can do to get the answer. Okay, if I know in triangle PQR, the distance I want to find is PR. So let me label it small letter Q, because it's the side facing angle Q. Now if this is 60 degrees, then this will be 30 degrees. This will be 30 degrees. That's 90 minus 60 degrees. And I know that this is obviously 90 degrees. That's 90 degrees right angle. So that means the whole of this is 120 degrees. 30 plus 90. So I can use that to find length Q by Pythagoras, by the cosine rule. So Q squared equals 500 squared plus 300 squared. I can just paste a small image of a diagram so that I can see it beside what I'm writing. Let me just paste a tiny image here. Yeah, so that means Q squared is 500 squared plus 300 squared minus 2 times 500 times 300 multiplied by the cosine of angle Q, which is cos 120 degrees. That's it. Now that simply means, let's work that out. 500 squared plus 300 squared minus 2 times 500 times 300 times cos 120 degrees. That's equal to 490,000. So Q is therefore the square root of 490,000, which simply means square root of 490,000 is simply 700. So that means Q equals 700 kilometers, and therefore the distance of the aeroplane from Ikeja Airport when it was directly above the road junction is 700 kilometers. Now to question B. Question B says the bearing of the aeroplane from Ikeja Airport at this instant, that's still when it was directly above the road junction. Let me paste the diagram here. I'm pasting the full diagram. So bearing of aeroplane from airport when it was directly above the road junction. The bearing of the port, the bearing of the aeroplane from the road here, from Ikeja Airport at this instant. So that means angle, this is Ikeja Airport, and this is where the aeroplane is. So bearing of the aeroplane from Ikeja Airport is going to be angle from the North Pole at Ikeja Airport to the line that joins the Ikeja Airport to the aeroplane. So that's this angle. That's the bearing of the aeroplane from Ikeja Airport. So how do I find that? I can simply call this, let me call this theta. If I call that angle theta, then it's simple. So I can just say 300, I want to write something here and then write it later. 300 over sine theta is equal to Q over sine 120 degrees. So that's what I'm using to find theta. So let me write that neatly now. 300 over sine theta equals q over sine 120 degrees, and that simply means 300 over sine theta equals, I know what q is, that's 700 over sine 120 degrees. When I cross multiply and make sine theta the subject of the formula, sine theta will be equal to 300 sine 120 degrees over 700. And let's do that quickly. 300 sine 120 degrees divided by 700. That's 0.3712. So that means theta is equal to the sine inverse of 0.3712, which is equal to sine inverse of that answer, and that's 21.787. But we are asked to approximate answers correct to the nearest 0.1 degree. So that simply means 21.8 degrees. So the bearing of the aeroplane from Ikeja Airport is 21.8 degrees, or you can write it as 021.8 degrees. It's the same. So that's very, very simply. Yes, I think we are going to take a break here and then come back for the remaining few. All right, thank you very much. I hope you enjoyed and understood that. So I'll see you in the next. Bye-bye.